Hi students, today we will discuss an advanced level question which is given in 2020. The topic is complex numbers. The question is, for a complex number z, the real part of z, the given, let S be the set of all complex numbers z satisfying z power 4 minus mod z power 4 equal to 4i z square. Now as we know that like mod z, so z power 4 minus mod z is nothing but z bar. Okay, so that is mod z square. So in case of that, I can write this one as z bar whole square because of mod z square equal to z into z bar, then that is equal to 4i z square. Now divide both sides with z square, so that here what will get z square minus z bar square equal to 4i. Next, it is in the form of a square minus b square, so that we can write it as z plus z bar into z minus z bar equals to 4a. Now we know that in the case of z equals to x plus iy and z bar equal to x minus iy, if we add these two, we will get 2x from this, and if you subtract these two, we will get 2iy is equals to 4i. Now can cancel 4 on both sides and can just divide with I, so that what will get xy equal to y, xy equal to 1 we will get finally. And we know that xy equal to some constant which always represents a rectangular hyperbola. Now if you observe this diagram, then xy equal to some constant which is represent a rectangular hyperbola, and I can write this one is y equal to 1 by x also, and we know that y equal to 1 by x graph, right? It will be like this, right? Now what he wants is then the minimum possible value of modulus of z1 minus z2 whole square, where z1 z2 belongs to that S, which is represented the complex numbers. Real part of z1 greater than 0 and the real part of z2 less than 0. Now they mentioned the real part of z1 greater than 0, which is nothing but z1 which lies in this portion, like here, wherever it is, z1 will be lies here in this branch of this hyperbola, and z2 will lies anywhere in this branch of the hyperbola, correct? So that if in the case why z1 lies here only means they mentioned clearly the real part of z1 is greater than 0, and here they mentioned real part of z2 is less than 0, so that z2 lies in this branch of the hyperbola and z1 lies there, and we want minimum possible value of z1 minus z2. As we know that modulus of z1 minus z2 represents the distance between two complex numbers z1 and z2, and we need minimum, so somewhere located here, right? Now can we say that if it is the minimum, z1 clearly will be here and z2 will be here, so while joining these two we will get a line like this, correct? So in case of this will be z1 and this will be z2, and this is the distance between z1 and z2, and clearly that is the line which always passes through origin, right? And if you observe that clearly, it makes an angle 45 degrees, and this is the line, if you observe clearly, that is y equal to x. So clearly, and y equal to x, and this one is y equal to 1 by x. After intersecting those two, this point should be 1 comma 1 and this point should be minus 1 comma minus 1, and the distance between those two is root over 4 plus 4, that is equals to root 8. And what we want, is like minimum. Modulus of z1 minus z2 whole square, and the minimum value is equal to what? 8. Thank you.